we're hearing from Rob Hanson, who's the Foundation Director of Data61's Digital Trust Institute and product owner of the Consumer Data Rights Standards. He's a senior researcher and futurist at CSIRO's Data61, where he was the lead author of their 2017 blockchain report. Please welcome Rob from Data61.
Thanks, sir. Thank you for the introduction and thank you for the invitation to be here this evening. Can everyone hear me okay? Yep, fantastic. Well, that's the first third of my presentation done, so we're half the way through. I would like to also join you in acknowledging the Indigenous custodians of this land as well. I think that's very important that we do that. So tonight is going to run in 3 parts. It's an act in 3, or play in 3 acts. So we have a little bit about me and why I'm here and what I'm talking about. And really what I'm going to be talking about is reflections upon the paper that we at Data61 did with you, the ACS. Then we're going to talk a little bit more of a deep dive into what a blockchain is for those who don't know what that is. And then we're going to have a little bit at the end about where it's going and what we're seeing in that space. Let's get started. So here are some blockchain reports which have gone out, much more fancier than mine. So before we get onto those reports, Data61, I presume we've all heard of Data61. We're just a business unit inside of CSIRO. We're 3 years old now, and we come from both NICTA and Data61. So we've got very long roots and a long pedigree in this space. People don't often know how large we are. There's about 1,300 of us. We've got about, we have the largest amount of PhDs in IT in the country. So we're quite large in that sense. In case you hadn't heard of CSIRO, we invented Wi-Fi. You're very welcome. Before I get on much further, I am going to talk about cryptocurrencies. I'm going to talk about ICOs and those sorts of things. Please, I am a researcher. This is not financial advice. If you want financial advice, there are places you can go. So this is the most text you'll see on any of the screens that I've got up tonight. This is just the citation of the paper or the report that we did with you about the future of blockchain. And I was consulted right over there, but it was a different crew that did this one. So this was 2030, a look at the future of blockchain in Australia. And it spoke about what had happened since I produced my report a couple of years ago. And since then, a few things have moved on as well. So we'll talk about that too. So there was only one major strategic foresight report. That was mine. The other one was a contemporary view of the state of the technology at the time. So 2 reports in tandem were produced. And since then, as I said, things have changed. So if you'd like to know more about blockchain in particular and some of the things I'm going to talk about tonight, you can go to that URL. You'll get the slide deck after this as well. So as I said, mine was not anywhere near as fancy as yours. So this was a quote from your president. Few technologies in recent memory have been as polarizing as blockchain, with positions divided into camps of blockchain evangelists and blockchain skeptics. The distributed ledger technology, and DLT is simply another name for blockchain. There's contention about what these definitions are, but essentially if you see DLT, it means blockchain. It was originally developed for the Bitcoin cryptocurrency. We'll talk about that in a moment as well. And it has been billed as holding the potential to revolutionize the internet and change the very nature of trust. So the work that I do is looking at Horizon 2 and Horizon 3. So as the introduction said, I'm the founding director of the Digital Trust Lab. What we're doing with the Digital Trust Lab is we're looking at technology and we're saying this is having a large impact on society. This is having a large impact on the world around us. So we need to make sure that we're getting trust out of these systems. Now, trust is a complicated subject and a talk for another night. But really, there was a lot of work here that was done in blockchain, which looked at the question of trust. And like I said too, I'm the product owner for the Consumer Data Standards. There's a thing called the Consumer Data Right, which you'll hear about shortly. The legislation will be coming out later this year. And then essentially what will happen is you as a consumer will have the ability to access your data, which is with a retailer, starting with the banks, and being able to access that and shift that around, the primary use case being product comparison. So to start with, can I get a better credit card rate? Can I get a better savings account by moving my data around? And that is all done in a trusted environment, and we set the standards for that. But what will happen eventually is we're moving towards a data market. So we're moving towards digitizing the Australian economy and answering old questions in new ways and answering new questions in interesting ways as well. So taking data, for example, from telecommunications and energy and answering questions in the fintech space around that. But to do that, you need to have a lot of trust in the system. Good. Okay. So some of the work that we do when it comes to strategic foresight is we deal with uncertainty, and people think that we're making predictions. We're saying this is the way the world is going to go. We're not. What we're doing is we're talking about the critical uncertainties in front of us and how we can engage with that. So what is your agency? What are the tactics? What are the strategies you wish to employ to move forward in this space? One of the reasons we worked with the ACS in this space is the question is, what sort of skill sets do we need as ICT professionals to successfully engage with emerging technology? So in this case, we were particularly looking at blockchain and the various components and derivations of that. But we're also asking questions about what sort of technologies do we trust, and how do we get trust out of the networks and systems that we are using now and into the future? So I thought the hype would have fallen away by now when I was doing this. So when I started doing this, one of the main things I was looking at in the graphs that I put forward, and this is from the report that we did together, was at the appreciation in Bitcoin, which is a cryptocurrency. And that kept going up and up. And at some point we said that bubble was probably going to burst, and that did burst a little while ago. But the interest in blockchain has not gone away. So fundamentally it started in the cryptocurrency space. We'll unpack that in just a moment. But the hype continues. There's a lot of interest in blockchain, and that's why I'm here tonight. Why is there a lot of interest in blockchain? Well, one of the reasons is because we are moving into what we are calling the fourth industrial revolution, sometimes Industry 4.0. This is where we start to have a lot of technology embedded into the fabric of our life. And when we do that, we need to look for ways to get trust out of these systems. So the head of the head of the Bank of England in 2016 came out and said, this could very well signal the start of the fourth industrial revolution. What are we talking about in that space? Well, really there's been 4 of these things looking back in time. The fourth one is characterized by a thing we refer to as cyber physical systems, or more recently, we're referring to them as cyber physical social systems, because we're talking about how do people and technology interact together, particularly when machines start to make decisions. And we'll talk about that in a moment and how blockchain can factor into that. So what we're going to do now is, for those who know what a blockchain is, I'm about to put an animation up of a current view of the Ethereum blockchain. For those who don't understand it, it's fine. We'll unpack that in just a second afterwards, but I'll bring it up. I'll talk about the key characteristics of this particular blockchain, and then we'll move forward. So moving from the right-hand side of the screen being the oldest blocks to the left-hand side being the newest blocks, what we have there is effectively a blockchain. This is the Ethereum blockchain, which is being used right now. That pool of dots over there, and if you go to the website, which is etherviewer.live, and you can go there, that'll be in the slide deck for you afterwards. You can see all the legends and unpack the information about how this is actually working. But that is the pool of transactions which has been put out essentially in a peer-to-peer network to be what's often called mined, to be put together onto a block. You saw that a block just went red, well timed. That block is what we call an uncle block. So it didn't quite make it. At one point in time in the peer-to-peer network, they put together the block was fine, but it was a contender. What had happened was the blockchain had forked. You might have heard of that term. Unfortunately, like a lot of situations, the term forking gets used in about half dozen situations in blockchain. In this particular case, what it means is we have the chain, we had a block added to the end. We also had a contender block there as well. So effectively, if the blockchain was behind me, we had one on the right and one on the left. We've got a situation where we need to resolve that. And what happens in this particular blockchain is it's called the longest chain wins. So another block was made on my right hand. So the one on my left fell away, and those transactions went back into the pool. The reason that I said that was to let you know why it went red on the screen and what that's all about with those lines showing how those blocks are connected. It's not linear in that particular sense, but I'm also underscoring the point that this technology is inefficient. It's not particularly elegant, but we're doing that to build integrity into the system. A lot of the technologies that underpin blockchain are quite old. Merkle trees, for example, which I'm not going to unpack tonight, 40 years old. That's used in this technology. The reason this technology emerged about 10 years ago was because we had the scale of resources which started to make its processing efficient. So the use of the internet, the use of spare computing resources, all of the electricity required to cool the servers and to power them hit a particular price point where it was okay to run these things at scale and we could get the functionality that we were looking for. Now that was the first generation of blockchain. We'll talk about that a little bit more in a moment. They're getting more elegant at the moment as well, and we're starting to find different ways of getting consensus, which is the term we use for when we build one of these blocks. Does everyone agree that this is a legitimate block and we can add it to the end of the blockchain? But there's a trade-off. And so a lot of people have been saying, I'm just going to throw a blockchain in, and the question really is, what value are you going to get from that? Why don't you just use a distributed database? We've had those around for a long time. We've optimized those. What value are you going to get out of it from putting a blockchain in? And I'm not going to lie to you, a lot of the times it's useful to use this to get your foot in the door and to have that conversation around trust. Oh, you've got a legacy system and you would like a new system. Let's have a talk about that, shall we? And not just, shall we put a new system in, but also, how are we going to get more integrity in the processes that we're running at the moment? And so it's a good way to start those conversations as well. Excellent. Okay, so here's my non-technical discussion of what this is. I can get a lot deeper, but for the purposes of time and the audience, we'll just keep it fairly high level. So, blockchain, break it down into two parts. We have the block and we have the chain. So the easiest way to think about it is like a spreadsheet. So I used to do enterprise risk management, and the problem with spreadsheets, as we know with information systems, is integrity. So who viewed my spreadsheet? Who updated my spreadsheet? Does my spreadsheet represent the current view and state of the organization? Or are there other versions which are more up to date, living on a thumb drive or a network share somewhere out there? How do I know what I'm looking at? So the problem that we're trying to solve here, primarily with Bitcoin, the first version of blockchain, was global consistency, but really what we're talking about is integrity. We're trying to solve for integrity. So what we do is we have spreadsheets. Everybody in the room here has a spreadsheet. It's all formatted the same way. So we have columns and rows all set up the same. What we do is we put a series of transactions in there. So I say, I'm selling something, so I put in my details in there. And I say, what I'm doing is I'm selling something to Michael. Michael's giving me some coin in return, a cryptocurrency, and so we put that into the ledger and that goes up into the cloud. So we both sign it so we know that it came from me and him respectively, and then we put it up into the cloud. It's a peer-to-peer network in most of these public blockchains, so it goes out and starts to make its way around the place. And then what happens is a whole bunch of these transactions go into the cloud, and at some point in time, someone comes along, they grab a whole bunch of these transactions and they put them down into one spreadsheet, and they use some special maths. We can unpack that if you'd like. And they go, here at this point in time, all of these transactions were correct. And they lock that spreadsheet. And then what happens is we use a version of the same maths that we did to say that that is legitimate, and we link that into the next spreadsheet that comes along. So what we have is effectively a chain of tables, a chain of blocks, and we just keep adding to it. So before, when I said it's inefficient and it's not elegant, this thing only ever gets larger, right? It doesn't get smaller. There's some research at the moment about how we can make this more efficient. So once these chains get quite large, and they do over time, how do we archive that and keep reference to that though? But the problem is, what we really solved for at the beginning was a digital cryptocurrency. Now, digital currencies have been around for quite a while. Reconciliation of these currencies was quite hard, but what we solved with Bitcoin was the double spend problem. Because if I gave my coin to Michael, how would you know if I offered you the same coin that I'd already spent that previously? Well, with the blockchain, in that case, you can go to this ledger, which only ever grows, and you can see the provenance or the history or the traceability of every step that that coin has taken. And so you know that, yes, at one point in time, I did have control of that, but now I no longer have control of that, so you won't receive that from me. So that was really the key underpinning issue that was solved at the time. We're talking, it was around the time of the GFC, and there was some mistrust in the banking and finance system, and the principal use case was, hey, can I get this through remittance overseas and not have to wait for the time lag for the institutions involved and for the cost overheads. Now, if you're going to do that, you're going to give up the safety and comfort of the regulations that are involved. And so if there's some fraud involved, or my wallet is compromised and the keys are stolen and I lose the coins, they're gone and I'm not getting them back, whereas the fraud situation would be handled in a bank situation. So fundamentally, that's what we were talking about. The genesis of this thing was, at the time, the internet had just become cheap enough for a whole bunch of people to get involved in this thing. And the reason we needed a whole bunch of people involved in this thing was the first consensus mechanism was known as a proof of work mechanism. So what that was a race. We said, okay, if a malicious actor is going to try and fiddle the books and commit some fraud and put up one of these blocks, and the block had something wrong with it, or they were trying to game the system or the market, they would have to spend more compute and more time to solve for that problem as compared to a good actor that was just trying to solve the puzzle that was put in front of them. So there's a cryptographic puzzle they need to solve. In Bitcoin, that challenge is made harder over time as computers get faster. So on average, it gets solved about every 10 minutes. That's why I didn't show you the Bitcoin blockchain on the viewer, because you'd be sitting there forever to watch for the next block to come along. That's why I had Ethereum up. But it's an inefficient system, right? It's slow, it takes a while. If it's 10 minutes to get a block together, and then through the empirical studies that we've done and other people have done, you really have to wait about 6 blocks to make sure that your transaction actually stays on the system and it doesn't become one of those red uncles and falls off. So if you're waiting an hour to see if a transaction goes through, you're not going to tap and go with Bitcoin. Just saying. That said, there's been some interesting developments in the cryptocurrency space, and I'll talk to you about those in just a moment. One of the other really interesting things when it comes to blockchain is right now we are still talking about proofs of concept. Now, I don't do too many of these blockchain talks anymore because there's a lot of hype about them. And I was talking before about the evangelists and the skeptics, and how my world is about trying to harmonize both of them and trying to find out what the reality and the truth is in the middle of that. So in a dematerialized asset like Bitcoin, the asset never leaves the blockchain, right? It's always there. And as far as we can tell, there's been no problem with that. The cybersecurity events you've heard have been about the wallets, which has been about the protection of the keys in individual servers and computers, has nothing to do with the blockchain itself. The challenge is when we start to talk about the translation of the real world, so physical assets and transactions, onto a blockchain and back again, right? On-chain, off-chain. If there's not fidelity in that transaction, then where's the trust? What's the point, right? So a lot of people say, hey, I've got a great proof of concept, I'm going to do this, and there's a blockchain, so I've got trust. Well, the blockchain does a certain thing there, but if you want to have trust in that transaction, you've still got this other process going on, and you need to look at that. Now, like I said before, it's often a good way to start that conversation. If somebody is interested in a blockchain, you can talk about that sort of thing, but that's not the end of the conversation. There's a lot going on there. Now, one of the useful things about blockchain is that it's essentially a state machine, right? And that's where we move to next with the second version of blockchain. We started to put compute on the cloud, basically, and we said this happened at this particular point in time, and you can roll it back, you can roll it forward, you can see what was happening when. And then someone said, oh, like a contract. We've had electronic contracts. This is a smart contract. Sometimes that confuses people, and people think I've got a contract. This is not a digitization of 800 years of case law. This is taking certain process and rules and putting them online and saying, right, we've agreed that under this condition, this thing will execute, and when it executes, we've agreed on what the outcome will be. Now, we've seen some spectacular failures in that place. So there's a thing called the DAO, the Distributed Autonomous Organization, if you'd like to look it up. And there was another fork in that one, which was different to what we spoke about before. And lots of people lost some money in that space. So when we're talking about blockchain, it's still very hyped, it's still very new. Make sure you understand the language that you're engaging with and that the other people are talking about. And also be mindful of what the scope and the limitations are of this particular piece of kit. So it is very powerful, it has its place, but there are certain limitations when you try to use it in a business setting. So this is a quote also from the ACS and Data61 blockchain report. And I'm just calling out here that there has been a lot of interest about this, but there's been a lot of really good work done, particularly by RMIT and UTS, around multidisciplinary work in this space. Okay, cool. You've got a smart contract. Excellent. We've got some people in the comp sci space. They can look at how that works. Maybe you want to change the consensus method and make it a lot faster. Maybe we don't want it to be a public blockchain. Maybe we want a private blockchain. We want to work out how we control that and how we permission that and what we do in those spaces. But also we want to bring the lawyers in and we want to understand what it means when we write something here and it's essentially indelible. It's tamper evident, but it's basically tamper proof to a certain level. But what happens when you can't change it, right? What happens when you write something to it and there was a bit of an oops and there was a data spill and you wrote something to it which is classified, or you put something on there and it's illegal? I know I work with a lot of lawyers and they work with emerging tech and they do a lot of proof of concepts in this space. They will not go near public blockchains because what happens if there is, and there is some questionable stuff on there, and you can no longer use that anymore, or you don't want to have that no longer on your own infrastructure. So there's lots of questions which are open in this space, and there's really good work done, particularly by Professor Jason Potts, who's doing work at RMIT, and my good friend Dr. Philippa Ryan. Pip is currently at UTS. She'll be moving to ANU in the middle of this year, and all I can say is watch this space. She is currently on the international standards, writing the standards for smart contracts at the moment, and I reckon that there is a lot more to come out in that space very shortly. So lots of good stuff happening around the place. As I said before, trust in this space is contextual, right? If it's a dematerialized asset, that's great. But if you're starting to talk about things in the real world, then that's slightly different. So there's a bunch of things which is interesting that's happening at the moment. So a lot of cybersecurity stuff, particularly with IoT. So when I do this larger talk, I normally talk about the number of devices and the amount of data which is coming towards us and the trends that we have seen in the last 10 years or so in this space. And I talk about if we want to harness the value from that, we need to be able to trust this data and these devices. So if we can use blockchains to start to get a bit more trust in the integrity around, say, the configuration of these devices or the output of these devices, then that's probably going to send us in some really good directions. And there's been some really good work done, particularly in the energy sector in Adelaide, of all places. There's a lot of work going on down there at the moment, looking into things like solar PV, and looking into IoT devices. Really interesting things in solar PV, like identifying an individual panel by a fingerprint, essentially, of the crystal structure and the way that it's receiving the light, and being able to digitize that through a hash and recording that onto the blockchain. So we know the power came from this particular cell. So there's some really interesting things going on in that space once you can start to digitize an asset and start to move that around the place. So this was a look at the activities that are going on in Australia around the place. But like I said, this was when the report was published. And since then, there's been a lot going on. So we certainly have a lot of startups, a lot of centers and those sorts of things. I would say that the balance is now starting to shift. Certainly, I've been up to the River City Labs, and there's a lot of interesting things happening up in Brisbane and in that location. Some really, really good stuff. You might have seen in the paper on the weekend, Leanne Kemp was in some headline news. So Leanne's use case is really interesting. So if we're talking about the problem with moving an asset onto the chain and off the chain, she uses diamonds. Diamonds are really good. They have about 35 data points, which are very hard to fake, right? It's all about cut and clarity and flaws and those sorts of things. And really they don't change unless you cut the diamond and change the diamond. But what we're talking about in this case is the provenance of that diamond. Have I seen that diamond before? Yes, cool. If I've seen it before, then I can trace the lineage and I can know it's not a blood diamond, right? If you want to cut it later on, sure, do that. We'll use a process to then find the children of that diamond and map that onto the blockchain. But really in that case, very, very usable. So the point that I'm making there is in some cases really useful, but when you start to talk about supply chains, and this comes up a lot in Australia because we are very keen to see a lot more transparency and integrity in brand Australia and our supply chains because our commodities are very valuable. It's not the case of putting the whole supply chain necessarily on a blockchain. It's finding those points of high value where we can say, right, there's a certificate service over here, like a hard copy physical certificate. Maybe we can digitize that, put that on a blockchain and remove that as a point of concern. So I used to be a fraud director and I'm working on my way to get my CFE. I can tell you that the number one fraud scheme is document manipulation. So if we can start to deal with these types of things, we start to deal with the hygiene of the system. And that's there because I thought it was really cool. It's from your ACS report as well. I really like the graphics that you had in there. Look, there's a lot more that I can talk about. I'm mindful I'm coming up on time, so I'll open it up to the floor. Any questions?